Hi all, this video will be about PCB design. If you want to make your own PCB, you first have to install an electronic design software. I use Kicad for its simplicity and also it's totally free. Open it and create a new project. Give it a name and we are ready to go. But first, a big thanks goes to PCBWay for sponsoring this video. Whenever you need PCBs prototyping, PCBWay is the perfect place for you, either for simple or really advanced design. They also offer 3D printing or CNC parts. Also, as Christmas is coming, you can also access to further discounts. Make sure to check them out. So, how do we make a schematic? We first press on A, and here we have all the components. So for example, C is capacitor, R is resistor, L is inductor, and D is for diode. When we want to add a component, we also want to assign its footprint that you can find on this drop-down menu at the right. A footprint is basically the hardware implementation of our symbol. As you can see, for this screw terminal we have plenty of them. Let's select one random. Now we use R to rotate the component and place it with a click. We can also press E on the component to access to its properties. Here we can also change the footprint and see other properties. Now let's make a simple circuit with an LED and a resistor. So always press A to add a component and R to rotate it, and click on the end of your component to add a wire. Here I'm modifying the footprint of my LED by using the symbol properties menu. Now we only need to add the resistor and the wire to the other end of our connector. The last thing you have to do is to see if your circuit is all okay. And to do this, we click on there and click on Run DRC. Now we want this circuit to be powered by the same input of, let's say, another circuit. To do this, we can press P and add a voltage rail. Let's place it here. And actually, let me modify the value of the resistor to 330 and duplicate this circuit with Ctrl C and Ctrl V. Oh, I forgot to add the ground, so let's press P and search for ground and place it. Now we run the DRC as before and we get 2 errors. This because our 2 power symbols needs to be connected to another special symbol called power flag. So we press P and search for flag. We connect the symbols and rerun the DRC. Now there should be no errors. Okay, now this is the schematic of my PCB. It is a simple random number generator that uses an Arduino Nano and a shift register to drive a 4-digit 7-segment display. So when I want to draw a schematic, I always tend to divide the circuit in smaller parts. The idea is to improve readability and have a more logical sense on what's happening in the circuit. You only have to click here in the rectangular shape and draw. So we have here the V-in circuit that consists in the screw terminals, a diode for reverse polarity protection, a switch to turn on and off the circuit, and a capacitor. This is instead the Arduino Nano circuit. It has all the labels to the other various components that you can add clicking here. And you can select if it is an input, an output, or something else. We have also this LED, and to explain why it's here, I usually draw a dotted circle like this and then write some text with a brief explanation. I also suggest to specify the color in the schematic, and you can use the value field or create a new field. Just click, press E, and then add the field. We can call it color and type whatever you want. Here we have instead a 7-segment display circuit that consists of the actual display and the famous 74AC595 shift register. I could have been more specific if I would but yeah, it's fine the way it is. Here there are the range and random switches, and under them there is range encoder, the one that we can use to change the numbers during range selection. And here I have the power flags enclosed. Also, if you have to share your circuit with others, or like give it a more professional look, you can compile these labels in here. As a side note, if you want to resize your page, you can double click and select your favorite size, or click on the top here and select the size. After you completed your schematic, you can enter the PCB editor and click on this icon. Now we are importing all the footprints from the schematic, but I have 4 warnings. These warnings are for the unconnected mounting pins, so they are fine. Now let's arrange the components. Those thin blue lines are the connection you have to make. If your design is not as simple as this, you will end up redoing your layout many times, but it's okay. I try to rearrange the components so that they are nice to see on board and make it fairly compact. I also added 4 mounting holes. To do this, just press A and search for mounting hole. Now it's time to route the traces. I'm using 10 mils and 25 mils. To add the size, just click on there and click on edit. Here you can add various sizes depending on your circuit. I often stick from 2 to 4 sizes for circuits. And yes, 25 mils for this kind of circuit is way overkill, but it's just to say that we use bigger traces for bigger current. And also don't go too down in size. 10 mils is fine for low power signals. By the way, if you want, you can use the PCBWay trace with calculator if you're not sure of what size to use. Back to our PCB, we can click on there and start to route. I will use 10 mils for the signal traces and 25 mils for the power traces. We can access the bottom layer by pressing pinch down or by just clicking here. Let's move forward a bit. This is the final design. As you can see, I completed all the routings and added some silkscreen. The silkscreen is this yellowish layer that we use for component reference or to tell the user what to do. For example, here I added the plus and minus at the input, here the on-off position of the switch, and the range and randomized text down here. To add silkscreen, simply click on the silkscreen layer and then you can add text and shapes. We can press Alt+3 and see the 3D render. Pressing F we can flip our board, and with X, Y and Z you can change view. And you can also toggle component visibility. As you can see, some of those footprints don't have 3D model, but we can always add one if we have one. Just select your component, click on 3D and select your 3D model. An absolutely important thing to do that can be your first thing or your last is to draw the board outline. So click on Edge Cuts layer and draw a shape that encloses all your circuit. Now let's say you finish your design. How do we get our physical PCB? Well, I highly suggest to you to install the PCBWay plugin. Just search for PCBWay in the plugin and content manager. You can then click on the PCBWay icon here and boom, you are ready to order your PCB. You can then choose if get the board already assembled or do it yourself. You can also choose quantity, modify the material, the PCB thickness, the mask color, surface finish and plenty other things. PCBWay helped me to make this video. The PCBs look super good and their red mask is fantastic. But now let's try our randomizer. Okay, so let's turn this stuff on. By the way, you can use a 9-volt battery if you want. Let's randomize. There we go, there we go, there we go. Okay, it seems to work. Now I want to try to use the range. So let's do from 12 is okay to let's use a small number, so let's do maybe 23. Okay, and now the numbers are all from 12 to 23. Okay guys, the video ends here. Thank you for watching. I'll see you next time.